All right, today we're going to be talking about Chapter 4, Lesson 2. This is all about negative exponents. So recall from yesterday that when we had, for example, 5 raised to the third power, the 5 we called the base, the 3 was the exponent, and this whole term was called a power. And then we looked at 5 to the first represents just 1 5. 5 to the second represents 2 5s being multiplied. 5 to the third represents 3 5s being multiplied. And as I increased the exponent by 1, I multiplied by 1 more base. So now what would have happened if I were to decrease the exponents? So from 3 to 2, I divide by 5. Same thing here, from 2 to 1, I divide by 5. So what if I had 5 to the 0? I divide by 5 again. 5 divided by 5 is 1. And if I were to keep going with this, 5 to the negative first power, again, would be another divided by 5. So 1 divided by 5 is 1 over 5. And then 5 to the negative second power would be, again, another divided by 5, which is going to be 1 over 5 times 5. That's really small. So as I increase, so 1 over 5 times 5, if I multiplied that by 5, I would get 1 over 5. And 1 over 5 multiplied by 5 gets me 1, and 1 times 5 gets me 5. So if I increase the exponent, I'm multiplying. And if I decrease the exponent, I start to divide. Notice here, though, that 5 to the negative first is 1 over 5, and 5 to the first it would be 5, or 5 over 1. Also notice that 5 to the negative second is 1 over 5 times 5, and 5 to the second is 5 times 5. So if I have a letter A, which could be any number, and I raise that to an exponent of negative n, where n is also any number but 0, this can be evaluated as 1 over a to the n. So this negative sign here on the exponent really tells us to make the reciprocal. Of a to the n. And here's the interesting thing. If I say that n is 0, I now have a to the 0. That will always be 1, even if a is 0. I think. Let me check. Yep, 0 raised to the 0 power is 1. All right, let's start looking at some examples. So example 1, it says write each expression using a positive exponent. So 3 to the negative fourth power. Remember, this negative sign means to make the reciprocal of 3 to the fourth, which means that this would turn into 1 over 3 to the fourth. Now be careful. This does not mean to do this. That is not true. The reason why is because if this were a negative sign out here, it would not like it. So letter B, we have m to the negative second. Now m can be any number. So I'm going to, again, make the reciprocal. And it's 1 over m squared, or 1 over m to the second power. All right, let's look at example 2 now. It says write each expression using a negative exponent. And that exponent has to be something other than -1. So what I want to do here is I want to start looking at what can I get or use as a base that'll get me to 125. And I could use 2, but 2 would get me up to 128 and not 125. 3 gets me to 81 or 243, so that doesn't work. 4 gets me to 64 or 144, so that doesn't work. 5 is 125, but I need 3 5s. So this is really the same as 1 over 5 to the third. So if I use a negative exponent, all of this would move to the numerator, and I have 5 to the negative third. Letter B, a little bit more easy, or a little bit more simple, a little simpler. So 8 raised to the 4th power in the denominator would get me to be 8 to the negative 4th power in the numerator. Last example on this side, it says an atom has a diameter of 0.000000001 meter. Write the decimal as a fraction and as a power of 10. So first of all, this decimal, this place value, we have to figure out what place value that is in. But remember, when we change a decimal to a fraction, whatever place value the last number is in is the denominator, and then whatever number is after the decimal is in the numerator. So far, the numerator is just going to be 1, because that's the only number. Now we have to figure out what the denominator is going to be. So this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millionths, 100 millionths, billionths, 10 billionths. So our denominator needs to be 10 billion. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. It says to now do it as a power of 10. So I'm going to have 1 over 10 raised to some power. I know that 10 times 10 is 100, times 10 is 1,000, times another 10 is 10,000, and another 10, and another 10, and so on and so forth. So I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. And to rewrite this as a regular power of 10, I would have 10 to the negative 10th meters. And that's a really small number. All right, last example. We're going to now evaluate. Again, use the order of operations. Use PEMDAS. Remember, this is parentheses. Parentheses. This is exponents. Multiply, divide, add, subtract. So this is the one we're going to focus on. And this comes before multiplication, so which means that we need to deal with the exponents before we multiply. So, evaluate 16r to the negative third if r is negative 4. So this really becomes this. Evaluating the exponents first. So this really becomes that. The 16 is not attached to the exponent. The exponent only deals with the number that's in the parentheses. So now I need to evaluate this exponent term down here, which would be negative 4 3 times. So negative 4 times negative 4 is 16, times negative 4 is negative 64. Then 16 divided by negative 64, I can pull a common factor of 16 out to simplify. So that becomes 1 over negative 4, which means that the overall answer would be negative 1/4. All right, that is the end of lesson 2. If you have any questions, please let me know. Otherwise, the rest of the time is for your work.